Hello everyone. Today I will talk about how to define functions. Functions are essential for creating reusable code, allowing you to organize your programs more effectively. Let's begin. To start, a function is a block of code that performs a specific task and can be reused throughout your program. It is similar to a recipe that you can follow multiple times. Functions promote code reusability, better organization, and modularity. Let me expand on that analogy a bit. Imagine you are baking cookies. Instead of writing out the full instructions every time you want to bake, you create a single recipe card. Whenever you need cookies, you just refer to that card. In the same way, a function lets you define a set of instructions once and use them repeatedly in your code, saving time and reducing errors. In Python, we define a function using the diff keyword, following, followed by the function name and parentheses. The code within the function must be indented. Here is a simple example in our Colab notebook, a function named sayHello. This function does not execute automatically. To run it, you call the function by typing its name followed by parentheses, like this, sayHello with parentheses. When I execute this, let's execute it, it displays hello world. Let's take a moment to see what happens step by step. When Python reads the def line, it notes that this is a function definition but does not run the code inside yet. Only when I call sayHello does it jump to the function body and execute the print statement. This separation between defining and calling is key to how functions work. Functions become more versatile with parameters, which are inputs that allow customization. Parameters are placed inside the parentheses during definition. Consider this example, a greet function that accepts a name. In here, calling greet Alice produces, as you can see, hello Alice. In this case, name is the parameter and Alice is the argument provided. To make this clearer, think about how parameters make functions adaptable. Without them, every greeting will be the same, but with a parameter like name, you can greet anyone, Alice, Bob, or even your own name. Let me show another quick code, like let's say greet Bob. Which would output, as you can see, hello Bob. You can pass different arguments each time you call the function. Now, let's move on with if a function needs to output a value for further use, employ the return statement. This sends the result back from the function. Here is an add function as an illustration. Now, let's run it. It returns 7, which can be stored in a variable such as result, sc. Let's break this down further though. Inside the function, a and b are parameters that receive the values 3 and 4 when called. The return statement calculates their sum and sends it back. Then outside, I store it in result and print it. Without return, the function would compute the sum but not give it back. So you could not use it elsewhere. For instance, if I remove return like this and just had a plus b, calling at 3, 4 will do the math internally, but produce no output for me to work with, like as you can see. You can also assign default values to parameters for cases where no argument is provided. For instance, in this introduce function, the greeting defaults to hello. The first call uses default value, while the second overrides it. Let's run it. This feature is useful when you want flexibility, but also a fallback. In the first call, introduce Bob, it assumes hello for greeting. In the second, introduce Bob and hi, you specify hi instead. You could even add more defaults defaults if a function has multiple parameters. And as you can see, while the first one is hello, the second one is hi. Also, just remember, default parameters should come after non-default ones in the definition. Now, regarding scope, variables defined inside a function are local and inaccessible outside of it. For example, in the scope, my function attempting to access x variable x outside the function would result in an error. To illustrate why scope matters, consider if x was accessible everywhere. It could lead to conflicts if another part of your code uses the same variable name. Local scope keeps things isolated, like having separate drawers for different tools. Now, if I uncomment that outer print x, Python would raise a name error because it does not know about the x from inside the function. Let's show it. Now, as you can see, it works perfectly. But if I uncomment this, it will give name error because of the scope. Now, some best practices include using descriptive names for functions, such as calculate area for calculating area, keeping functions focused on a single task, and adding comments to describe their purpose. Let me add a few more tips here. I would suggest to avoid using global variables inside functions if possible, as it can make code harder to debug. Also, test your function individually. Call them with different inputs to ensure that they work as expected. And remember to keep the function body concise. If it gets too long, consider breaking it into small functions. Now, to conclude, I will build a practical example, a function to calculate the area of a square. I will write the code step by step right now in this notebook. First, let's type def square area and site as a parameter. This defines the function name and the parameter for the site. Next, indent and add return site times site, like this. This calculates the area of a square and returns it. Now, outside the function, add print and our function, which is square area, and let's give it like for site, let's say 5. Now it calls it with its site as 5 and displays the result as seen 25. As you can see, when I execute this, it outputs 25, demonstrating the reusability. Let us try calling it again with a different value to see the reusability in action. For example, print square area 10, like this. It gives 100, or printing square area 2.5, which would give 6.25 for a non-integer site. This shows how one function can handle various inputs without rewriting the code each time. This video covers the fundamentals of defining functions. Thank you for watching.